I will invite Alex from BEA Consulting International. Again, a Netapp that is being developed in another similar project that is Vital 5G. We'll hear a bit about the Netapp and then a bit more in general, a quick overview of the project. So, Alex.
Okay, so hello everyone. So I'm Alexander Volpe, and I'm going to present another project called Vital 5G, and especially a network application that is developed in the framework of this project. It is there are two types of network applications, and here we will present a vertical specific network application. There are also vertical agnostic network applications. So we are targeting onboard data collection and interfacing for a river vessel. So NAVROM is a Romanian river transport company. This is the content of the presentation. Just one slide about the company. So we are BEA Consult International. We are new members of the 5G PPP. However, we have over 30 years experience in running IT and communication projects. And among many R&D projects that we are developing, we are also involved in a series of 5G for smart mobility, not only river, maritime, but also automotive and so on. And we are also good partners in different academia and industry, both in Romania and in Europe. I'm going to say a few words about the use case, so just to bring a little bit of context. The use case is called the 5G connectivity and data-enabled assisted navigation, and it's placed in the port of Galați. So it's in a river port of Galați on the Danube. We have a series of KPIs. You all know this, and among the standard KPIs, service creation, time, latency, and so on, but also some business and service KPIs. So there are some issues that the port is faced with, and we are targeting a decrease in a series of logistics costs, dangerous navigation events, and of course, accuracy of electronic navigation maps using services developed together or based on one or multiple Netapps. So there is specific hardware that is used for ship. You can see here an example of a ship and placement of different, let's say, mostly specific sensors that you see here. Also cameras and AIS transponders, depth sensors, and so on. Here we, let's say, rely on an extension of testbed from Orange. Probably you know this. And you can see that, let's say, we extend, Orange can say more about this. We extend the functionality of the testbed to the Galați with different capabilities. It's mainly based on an evolution of the testbed in 5G. So we can make also a comparison in the Vital 5G use case in the form of a radar graph with business requirements, facility requirements, as well as latency requirements. We have a series of targeted scenarios within the use case. So, for example, collision avoidance, adverse condition broadcasting, and emergency messages dissemination. So one example experiment using onboard data collection. So this Netapp record the measured values of depths and images, transmitting them using this Netapp, and it can provide specific information, for example, a machine learning module that is in another vertical agnostic Netapp, so VA2 in this case. So moving on to the specific Netapp, this is let's say simple conceptual architecture in which data is collected from the onboard sensors that are installed, and from video cameras, and the data is made available for this for the local onboard server, and also to and from external edge nodes and 5G network. The left side of the picture is more vertical specific, together with the interfaces in the data repository. To the right side, it can be also part of other Netapps. So the core data processing relies on what is being developed in the company. So a flow composed of MQTT used for data transfer between sensors in the testbed, Node-RED for different data pre or post-processing, an InfluxDB time series database, and optionally for simple visualization and alerting, we use Grafana, but of course from the database, data can be made available for other engines. There's a more in-depth description of, for instance, a depth sensor and the issues that are surrounding the hardware development and how to process the data and send it. So it's not easy. We are currently fixing all sorts of issues related to this sensor development, and we are pushing data onwards. The main flow is this MQTT broker that via an adapter, which is also custom developed by our company, brings it to the InfluxDB and then to possibly to the visualization engine. So this is an example. For instance, we have our own MQTT broker, which is public, and you can see here examples of data that is coming from a ship, complete with AIS coordinates and other information about the ship. A Node-RED flow can also acquire data from a specific telemetry server and can send it to an MQTT broker. And for instance, we can see also some example of visualization. For instance, sensor data that is used for measuring water depth. We can also show an example of a service. This is an example of accurate electronic navigation maps, right? In which our vertical specific VS9 Netapp is also pushing data towards a vertical agnostic VA2 Netapp. So you can see that here a service is, let's say, composed of multiple network applications. So the VS9 is, let's say, like you could say an atomic component maybe, and that provides data for multiple other Netapps. These are an example, a list of technologies that are mostly used in the development. So they are all open source. The VS9 is mostly open source, so we have our GitHub page, and there is also Vital 5G public repository in gitlab.com, where you can see an example. You can see the early drop of the VA2, which uses behind the VS9, and you can look for you can see the code there. And how is it part of the 5G TNL ecosystem? So first of all, on the vessel side, there are 5G devices that are using either URLLC or EMBB slices, depending on the service that we want to deploy. And of course, the requirements for 5G networking. And it's also specifying what is called the Netapp blueprint, which is, let's say, a skeleton specification of the requirements of a Netapp. And you can see there the requirements from a 5G network viewpoint. So just a few conclusions. First of all, these vertical specific Netapps are highly dependent on available devices. And it can be used as input for other Netapps, either in this case or In other use cases, we are still to test it over the 5G network, so we're still in laboratory testing, as well as higher level NetApps that are under development. And finally, we plan to measure all the service and network APIs and validate the Netapp and the use case. Yeah, thank you.
Thank you, Alex. Let's see if we have anything here. Nothing in the chat. One here.
Thank you for your presentation. Can you give us an example of the VA2 Netapp, an example of Netapp that you have in the VA2 with machine learning that you are using?
So VA2 is another Netapp that is being co-developed partially by Bea and partially by a company, Intelligence, from Greece. They are handling the machine learning module, so the data that we are sending using VS9 is used by the machine learning part of the VA2, which will do different things according to the use case. So, for instance, risk assessment, something like that. You can go to the deliverables of Vital 5G. You can see there a description. You can also go to the repository. I'm sorry, I didn't put a link in the slides, but you can go to the GitLab repository and you can see there the early drop of the VA2. It's in the public repositories. So I'm not I cannot comment on the machine learning part as I'm not a specialist in that part.
Thank you.
Thank you.